Hey guys, today we're going to just measure the range of my potato cannon. We already figured out the initial velocity. We're going to use this slide for our angle.
All I care about. Going up. I shoot over this into this field.
Yo, wouldn't it be? When we just measured it.
Got him?
I'm getting 28 consistently.
Okay, that's what we're looking for. Max?
Get up at the barrel though. See if it changes at all. 28?
28.
28 it is.
String right there is measuring a distance. It's very rudimentary, but it should work. Fire. Failure on the ignition switch. Set. Test 3. Fire.
Potato. Okay, so we first need to find the velocity initial of the potato gun. So we're going to use the range equation, which of course is range equals velocity squared times sine 2 theta over 9.81. So we've measured out the range. The range is 123.44 equals velocity initial squared times sine 2 of 28 degrees over 9.81. So 123.44 equals, can I get the sine of 56 please, Max?
0.82.
9.81. 123.44, so we got to times that 9.81. 9.81. Can you get 9.81 times 123.44?
9.81 times
123.44.
1,210.9.
1,210.
Yep, 0.9.
Okay, equals velocity squared. And can you divide that by 0.82, Max?
1,476.8.
And can you take the square root of that?
38.4.
Okay, so the initial velocity is going to be 38.4 meters per second. Stop it. Okay, so now we're going to find the range that should happen if we fire this potato gun at 89 degrees given our calculated initial velocity. So the range is going to be the unknown variable, and our calculated velocity is, what's your calculated velocity? 38.4 squared times the angle, so sine theta 2 of the theta, which in this case is going to be 89 degrees. It's all going to be over 9.81. So R is going to equal, can I get 38.4 squared, please, Max?
38.4 squared. 1,474.5.
Okay, and can I get the sine of 178?
0.035.
Over 9.81. Alright, and can I get 1,474.5 times 0.035?
51.6.
And can you please divide that by 9.81 for me?
5.2.
5.2 meters. So the range on 89 degrees, assuming that we are in a vacuum and also that there is no air resistance, it should go 5.2 meters. Okay, so our calculation from our theoretical indicated that our potato should have gone 5.2 meters. We measured it to 18.3 feet, so we're going to convert that quick. 18.3 feet is equal, or times 1 meter over 3.28 feet, because that is the conversion rate of feet to meters. Max, can you do that for me? 18.3 divided by 3.28.
5.5.
5.5 meters. Obviously, we're a little off on this. There's a couple reasons that could be the case. Number one, we had a strong northeast wind. It was about 10 miles per hour, so that could have affected it. Additionally, in our calculations, we were accounting for no friction, no air resistance, nothing like that, which could also have caused it to be off a little bit. But relatively speaking, we're pretty close on that. 0.3 meter error. I'm pretty sure that'd probably be a pretty low percent error. So, yeah, overall, it was close, and that concludes this test.
This is 89 degrees. We did a range equation. So I should go about 5 meters. We shouldn't be under this.
It's coming down right there. Aha!
Alright, potatoes right here. And it measures out to 18 feet.
Potato in the engine. Potato in the engine. Fire. Okay.
Alright, so we have max down range. He has a baseball glove in his left hand, and he is going to try to catch this potato, which we are going to launch horizontally at him.
I recommended we shoot it straight at him, but that was denied.
No killing Max, I guess.
All right. Hopefully this works. Ready?
Fire. It's going left.
You get it? I think I saw a flash.
I don't think he got it. Hey! Attempt number 2 with the potato cannon.
What's your team is in place?
We're going to catch better footage this time. All right, 3, 2, 1, fire. All right, this time we're going all out. We're going to fire it on this, a little lower, a little lower. We're going to try and kill Max.
3, 2, 1, fire.
It's going. It's going. It smells awful and it's gone! All right, so we are now testing this potato gun on Shook Up Diet Coke. And we are, about 12 feet away.
I'd love to see Max miss this.
So would I. No, actually I did. Alright. No, let us aim it for you, dude. Charlie, you aim. I gotta get an actually decent shot.
Fire when ready, Gratz.
Michael. Alright, so we shrunk the distance from 12 feet to about 4 feet. Alright, so let's see if you can actually hit it this range. So this is our third attempt trying to shoot it. We're gonna get even closer because we can't hit it.
Whatever works. Yo, get closer, Max. We can't miss this time.
You've got a point. This one's for dignity. If you can't do this,
Closer?
you should not exist.
We're gonna miss.
1 second, I'm gonna get a barrel view just to make sure. Alright, so this is it. This is it.
Go. Hey! Got him. Alright, that's good. Take it. We'll take it. That's it.
Fine. So our damage is pretty
Significant.
For the most part.
Are these even punctured? Nope. Never mind.
Very bad.
So we can't even puncture
Dented, at
shaking
least.
up aluminum or soda.
Aluminum.
So
Firing. Ready?
go.
Failure on ignition.
Wow, this is like every other time. Actually, no, every time.
Max's wiring is not exactly great, I would say. Firing. Hit Max. Failure.
Yeah, we're gonna hit Max.
Let's hit him.
Kill. That was so sad. After 7 attempts,
Try it one more time.
we're gonna try and fire this potato.
Three, two, one. Failure.
Never mind. Attempt number 25.
I'll sign at the cross for it. Fire.
And she's back.